I've finally jumped on the AI trend, and to prove my commitment to the cause, I've just built a tool to put myself out of work. It's an Agentic analytics app. You ask the agent a question, and it goes to the database to answer for you. No analyst manually pulling queries, checking tables, or writing up the response in the background. Under the hood, the agent is using structured context that's embedded inside the database itself with the help of dbt, vectorized semantic search, and a Claude agent workflow. But the obvious question that follows is, how do I, and of course you, know whether this agent is actually any good? We can't just go by gut feel and a few ad hoc checks here. That's not good enough. So, to test it properly, I built a structured evaluation framework which measures how well the agent performs across a set of realistic analytics questions. And I don't just look at whether the final answer sounds plausible. I also measure how much it costs to run, how many steps it takes, how many SQL queries it executes, and whether it gets caught by known traps or ambiguities in the data. What we get doesn't just evaluate this one demo agent. It creates a foundation for long-term governance, testing, and control so that we can compare future LLM releases, track whether the agent improves or degrades over time, and monitor how performance changes as the business and knowledge base evolve. So if you think this is cool and you believe it could improve the quality and velocity of data-driven decision-making at your company, I'm available for hire. Don't be shy. Drop me a DM, crypto or otherwise, I'm here to help. And if you do have some more time now, stick around. I'm going to walk through the key concepts and components of this build and share a few thoughts about what it tells us about analytics in the agentic AI era. Let's start on the main page. This page is designed to show you how the analytics agent responds to the questions that are given to it. You can select a question from this drop-down list here, and once you click on it, you'll see that underneath, these two response panes begin to populate. The pane on the left shows the response from the simpler baseline agent. This is the agent that's working mostly from the raw database, table names, column names, and natural embedded comments. The pane on the right shows the response from the agent that has access to the additional knowledge stack, so dbt context, richer metadata, and additional documents. For each response, you can see that we get a full itemized breakdown of the key actions taken by the agent, including all the SQL code that the agent executes against the database. And right at the bottom, we have some performance metrics quoted as well, including the cost, the number of turns taken by the agent, the time taken, and the number of queries executed, along with a confirmation of whether it hits the right answer or not. If we look at this particular example that I happen to load, we see that the costs are actually dramatically lower on the optimized agent. It takes about half as many turns and a third of the amount of time as the unoptimized agent, even though both actually get to the same results. So you see that it's not just about getting the right answer. Insight and analysis of performance is also critical in this process. Now, this demo app was built subject to a few constraints. First of all, I didn't want to pay for everyone else's LLM queries. Second, I didn't want to ask you to trust me with your private API keys. And third, the underlying data set concerns blockchain protocols, which not every viewer is going to know that much about. That's why this demo works with a list of preset questions here. When you select a question from the drop-down, what you're seeing is not a fresh live run, it is a replay of a real pre-recorded response that each agent has given to this question. You can replay these responses in real time, or you can speed them up with these buttons here, or go straight to the end result. So the intention and purpose of this page is to give you an intuitive feel of how these two agents behave. It makes the comparison tangible. But by itself, this does not give us a broad or rigorous evaluation of whether the optimized agent is actually better than the baseline agent. For that, we need the results page. This is the most important part of the project, so it's worth spending a little more time on it. Let's start from first principles. We are engineering a tool that is supposed to give high-quality, accurate, reliable answers to chat-style analytics questions. So the basic structure of the test is simple. Give the agent a set of questions, record what it does, and evaluate what comes back. The preset questions on the demo page are not just there to support users with limited blockchain knowledge. They are the test set that has been used for this experiment. Now, you might object to this methodology. If the whole point here is to build an agent that is able to handle new and unexpected questions, isn't testing it against a fixed question set defeating that purpose? I think that's a fair pushback, but I don't think it's actually a problem. A fixed question bank gives us a measuring stick. It gives us something stable to compare against when we change the agent, change the model, or change the knowledge stack. It doesn't mean that the fixed test set is the whole evaluation process. In a production setting, you'd also want to collect examples from real user behavior and use those to expand and improve the test suite over time. But you still need a stable core set of questions. Without that, you can't really tell whether the agent is improving or just behaving differently. The important thing is that the questions are not chosen at random. They're grouped into categories that test different capabilities and failure modes. Some of the questions test whether the agent can answer narrow factual questions. Some test whether it can handle broader, more open-ended analytical prompts. Some test whether it will get tripped up by known ambiguities in the data. And some test whether it will hallucinate answers to questions that can't actually be answered. So question selection is not a small detail here. It is tightly connected to defining what we need this agent to be good at and where we are most worried about it failing. Once we've defined the question set, the next issue is the experimental design. If we just test one agent and get one set of results, that gives us some information, but it doesn't tell us much about what is actually driving performance. So in this experiment, I focus specifically on the knowledge stack. I run tests against 4 different knowledge conditions. The most basic one is the baseline. The agent can see the tables, column names, and data, but has no additional context. The next condition gives it access to all of that, but then also adds the explanatory comments that have been added into the database using its native commenting capabilities. The third condition adds DBT context, model definitions, relationships, tests, documentation, and the semantic structure that's governed throughout the DBT project. And the final condition adds a broader document layer: business context, protocol documentation, research notes, historic events, and other material embedded into the database itself for semantic retrieval. So we're not just asking, is this agent any good? We're also asking which knowledge layers actually help the agent perform better and on what types of questions. Let's take a second to recap where we are. We have a fixed question set selected to test different capabilities and failure modes. We run the same questions under different knowledge conditions, and then we need a scoring framework to evaluate the results that we get back. For scoring, there are 2 broad areas that I care about: answer quality and operational performance. For answer quality, there are really 2 types of questions. First, questions with a known correct answer. For those, scoring is relatively straightforward. Did the agent return the right factual result or not? In the second case, we're dealing with open-ended questions where the answer has to be grounded in the facts that exist in the database, but it cannot be reduced to a single simple answer. For these open-ended questions, I use a separate blind judge to score the response against a composite set of criteria. Now, obviously, this judge is itself AI reliant and imperfect, but at scale, we just don't have many low-cost alternatives. The practical answer is to not pretend that the judge is infallible. Instead, what we need to do is review it carefully up front, spot check it periodically, and treat it as one component in a broader evaluation system. The next evaluation category is our operational metrics, which are more objective. How many turns did the agent take? How long did it take? How many SQL queries did it run? What was the estimated cost? How many errors or blocked actions were triggered? These metrics matter because a technically correct answer is not enough. If it takes too long, costs too much, or gets there through a messy and fragile workflow, that matters in production. So between answer quality and operational performance, we now have a framework that lets us evaluate agent behavior in a reasonably rigorous way. And that is the key point. Even though these systems are open-ended, non-deterministic, and somewhat opaque in execution, we can still build useful testing frameworks around them. We can still measure them, we can still compare them, and we can still manage them over time. I also think this highlights something important about the future role of analysts. The real value is not just in manually answering stakeholder questions one by one. A lot of that work can probably now be automated. but a new responsibility opens up around designing and maintaining the context that allows these systems to perform well. That includes choosing the right questions to test. It includes understanding the business well enough to identify important failure modes. It includes shaping the DBT layer, the semantic layer, the documentation layer, and the evaluation layer so that the agent remains aligned with how the business actually operates and its goals. So yes, this tool may put me out of a job as an analyst who simply answers recurring stakeholder questions, but it creates another job, helping businesses set up and maintain high-quality analytical context so that these agents remain useful, reliable, and grounded. Now, let's scroll down to briefly look at some of the results of this run. I won't walk through every single row, but I think there are a few interesting observations here. First, we see the clearest improvements from richer knowledge resources show up in more semantics-heavy parts of this test, especially quantitative questions and known data traps. Second, these gains aren't uniform across every category. On some quantitative questions, a lot of the improvement already comes simply from adopting standard commenting practices inside of the database. In other cases, especially the trap questions, DBT context and analyst playbooks matter more. That's interesting, but I want to be careful about overinterpreting it. These results are local to this specific dataset, this specific question set, and this specific agent design. They may reflect a number of contingent facts. The question set may not be large or demanding enough. The data set here is relatively small. The underlying activity we're dealing with is narrow in scope, and blockchain data has some unusual features, given that it is generated by a bunch of programs designed to keep and maintain a ledger. That may make some of the relationships cleaner than they would be in messier operational businesses. So I wouldn't take these results and generalize too aggressively across all business contexts, but that's absolutely fine. The goal here is not to prove some universal law about agentic analytics. The goal is to create a consistent and methodical way of evaluating agent performance within this specific business and data context. And that in itself is highly valuable. Okay, that's the most detailed part of this walkthrough done. The remaining pages go into more detail about the tooling used to create the agent and the different knowledge components that it draws upon. These parts are more straightforwardly descriptive, so I'll cover them more lightly. In the Architecture tab here, I list the main tools and components that are used in the build. I separate the parts of the system that represent knowledge resources from the parts that guide and control agent workflow behavior. So on one side, you have the database, the DBT, metadata, semantic embeddings, and document corpus. And on the other side, you have the agent workflow, tool access, MCP wrappers, evaluation harness, and the constraints that control what the agent is allowed to do. The next page covers the DBT knowledge layer. This goes into more detail on the specific DBT elements that are being used to enrich context. Model descriptions, column descriptions, facts about the nature of the source data, relationship tests, and other metadata that help the agent understand what the data means, not just where it lives. And there are also links to a separate Explorer page here where you can inspect the DBT model in more detail. After that, we have the RAG corpus. This lists the documents that have been embedded and connected to the database through semantic relationships. Because this demo uses blockchain data, some of those documents describe protocol mechanics and program execution, but I also include research reports that are generated from earlier analysis. And I think that this is the most interesting category because each time we create a report or analysis artifact, we're not just summarizing data, we're also adding business context. We're explaining why the analysis matters. We're connecting the numbers to decisions, risks, events, and stakeholders' concerns. If you loop these artifacts back into the system, you start building a kind of analytical memory. The agent is no longer limited by its raw data. It can begin to draw on the history of what has been analyzed, what mattered at the time, and why stakeholders cared. That is where I think a lot of the potential sits. Not just in asking an agent to query a database, but in progressively building the business context that allows it to answer better questions over time. And well, there you have it. That's the walkthrough of this Agentic Analytics demo. We have the agent interface, where you can compare baseline and knowledge-enhanced responses. We have the testing framework, which allows us to evaluate answer quality and operational performance more broadly and systematically. We have the knowledge stack, the database metadata, DBT, context, semantic retrieval, business docs, all of which help the agent to perform better. And I hope you found this presentation interesting. If you're interested in building out these sorts of capabilities at your own company, do reach out. You don't have to be in crypto. I'm comfortable thinking my way around all kinds of business models and domains. The core problem is usually the same: turning messy data and messy context into systems that support better and faster decision making. Until next time, be well.